All right, so we have a few classes here with us today, so welcome. We'll go ahead and get started so we can maximize our time today. So welcome, future makers, engineers, and innovators. We're so happy to see all of you joining us today. Before we begin, I wanted to go over a few housekeeping items. First of all, please introduce yourself in the chat box if you haven't already. Tell us the name of your school and your current class that you're with. What grade level are the students that are attending today's session? Let us know the class size and how many students are joining us. And if there's any community guests on or BAMA members, please type the name of your company in the chat box and let us know what your interest is in manufacturing and Manufacturing Day. And also feel free to ask any questions you have. So you can type them in the chat box, but we'll also have some time for Q&A all throughout. So you can either ask the questions directly or you can type them in the chat box. So my name is Beth Gallick, if you don't know me already, and I'm the Executive Director of the Bay Area Manufacturers Association, or as we're better known, just BAMA. BAMA is an industry-focused membership organization. So we serve manufacturers here in the Tampa Bay area. We are 62 years old, so our organization's been around for 62 years. And we're membership-based, so manufacturing companies join BAMA, and we help them in a variety of ways. So our mission is to advance Tampa Bay manufacturers through workforce development, networking, education, advocacy, and technology. And we are the official representative of the Florida Makes Network in the region. We are thrilled to have you join us on this exciting webinar as we kick off Manufacturing Month. And Manufacturing Month, if you don't know what it is an annual event, and it's executed locally with the support of thousands of manufacturers across the country as they host students, teachers, parents, job seekers, and other community members at open houses, plant tours, presentations designed to showcase today's advanced manufacturing technology and high-wage career options. So imagine a world where you can create, build, and shape the future. Well, guess what? You can do that, and it starts right here and right now. Manufacturing isn't just about producing things, it's about turning ideas into a reality. It's about pushing the boundaries of what's possible, and it's about the future, and you are the future of manufacturing. So in the next half hour, we're going to explore the thrilling world of manufacturing and uncover the incredible technology shaping our world. We're going to introduce you to the minds behind the magic. We've got engaging discussions and fascinating stories straight from the manufacturers themselves. So to kick things off, we are starting with a company located right here in the Tampa Bay area. The company is Southern Manufacturing Technologies, and the gentleman joining us is the owner of the company. He has grown the company from the start, and he has a lot of fascinating stories to tell you about manufacturing and to tell you about what it's like to work at SMT and what they do. So I would like to welcome Roy Sweatman from Southern Manufacturing Technologies.
Thanks, Beth. Good morning, everyone, and thanks for joining us for this. We hope we'll enlighten you a little bit about manufacturing in the Bay Area. I'm assuming that everybody has watched the video, so you have some pretty good idea of what we do. SMT is a high-end machining company, so we're using computer-controlled CNC machines to remove metal, take a block of aluminum or stainless, and by cutting portions of it away, turn it into something that's used. Our customers they manufacture aircraft, aerospace, defense, space. We have parts in piston engine airplanes that a private pilot would fly, like a Cessna or Piper. We have parts in 737s, Airbus A320s, F-15, F-16, F-35 fighters, Javelin missile, Tomahawk missile. We have parts in space up on Mars. We're part of all the Mars landings and we've made parts for the Artemis mission, which is due to land on the moon. So we have parts on the Orion capsule. So to work at SMT, if you come in with no experience at all, we'll start you at some entry level positions. You'll learn how to maybe saw material up. You'll learn how to measure through all the features that we produce on parts have to be measured to extremely close tolerances. I mean, sometimes we will hold tolerances on parts on a feature that is 10 times finer than one of your hairs. So to like 2/10,000ths of an inch or something. So learning that and developing those skills to be able to use sophisticated measuring equipment and measure those kind of features is important, because you can't really make a good part unless you can measure it and know that it's good. But we have career pathways. We have a full apprenticeship program. We currently have 12 apprentices. So you're getting most of your learning on the job. And then there's a certain amount of related training that is done in 2 evenings a week over at Pinellas Technical College. And by using NIMS credentials, which NIMS is the National Institute of Metalworking Skills, we set the standards for machining skills levels and do testing and issue credentials for that. So with your time on the job, your related training, and making a certain number of parts that meet the NIMS standards, you can complete your apprenticeship, if you're really ambitious and want to work at it, in probably 2.5 years. I started my career as an apprentice. Back when I started, there was no competency-based NIMS credentials involved. It was an 8,000-hour, 4-year apprenticeship. So I spent 4 years finishing my apprenticeship, and that included night school 4 nights a week. But it has gotten me, that was the career start that got me to where I'm at now. So I've been a business owner here of SMT since 1983. So we celebrated our 40th year anniversary back in March, and we're growing, and we have many, many opportunities for people who want to be in manufacturing. While we promote machinists and inspectors and that kind of a thing as the main core of our people, but we have purchasing people and accounting people and shipping and receiving, and there's all kinds of opportunities. Engineering, a typical career path could be you start out entry levels, you learn how to run the CNC machines, you learn how to set them up, then maybe you go into programming and become an engineer and learn and be able to process the parts, take the drawings our customer sends us, and figure out what machines, what material, what tools to use, what program the computers and that to make the parts. And you could be a business owner someday. So I guess that's a little bit of a synopsis of what we do. Any questions from anyone?
Okay, we have a student question at Dunedin. Do you want to ask it? Okay, one question. How old do you have to be to begin there?
We have hired as young as 14. 16 is the minimum age to actually be out in the shop. If you're under 16, we would put you in inspection and maybe data entry and some things like that. At 16, you're able to run certain machines and learn certain things, not the open machines like saws and that, which could be considered a little more dangerous. But then at 18, you can pretty much do anything. And we do have several, I'm not sure right now, 3 or 4 high school students that are working for us part-time.
Good question. Do we have any other questions?
We do have one more. Go ahead, Warren.
So I saw that you were.
Come close, come up here.
So you said your company used adductive manufacturing, taking material away from a block. Are you thinking about expanding to 3D printing?
No, we're not. I mean, 3D printing has its place, in our kind of business. The material properties that are used in aircraft have not been fully duplicated in 3D printing. 3D printing is good for prototypes, good for fixturing and some things like that. But at this point in time for aircraft and that, it's very minimal use as far as production goes. They're still very, very slow compared to the subtractive machining that we do.
Do you do any 3D printing at all with for maybe tools or anything else at the facility, or no 3D printing at all?
At this point, we do not do any 3D printing. We've looked at it. I'm sure at some point in time we'll get into it. We have had fixtures made by 3D printing by another company that specializes in that sort of thing.
Okay. And Roy, we have a question in the chat. Are your internships paid?
Yes, we don't call them internships. They're really part-time work, but yes, we pay. We have been starting high school students in the $13 an hour range. If you're already graduated, probably $15 to start.
All right. Do we have any other questions? So ask away. You've got Roy's attention.
It's hard to get my attention, so.
He's a very busy man.
One student wants to know, are you hiring right now?
Depending on the circumstances, experience in that, yes, we would consider hiring somebody right now. Even entry level.
And Roy, what does a career path look like, at your company? Is there a chance for growth when someone comes in and they start in one position? Is there a chance for them to learn new things or to have a career path at your company?
Yeah, I talked about it a little bit earlier, but yes, we we'll promote. We try to promote from within as much as we can, and our apprentices. Part of the apprenticeship program is that you work in different areas. You learn CNC lathes, you learn CNC mills. We have verticals and horizontals, different types of machines. So, and of course the metrology, the measurement of everything. So there's all kinds of career paths. From like I think I mentioned earlier, you can be an operator up to a setup person and learn programming, become an engineer. You can become an inspector or a quality engineer. There's really no end to the different kind of opportunities that there are.
What kind of qualifications are you looking for a new hire to have?
Well, certainly a good attitude and ambition. It's not machining and the manufacturing business that we're in, the kind of close tolerances that we hold requires a lot of skill, and you don't learn that skill in 60 days. You're not going to come in here and take my job in 3 months. But if you're mechanically inclined, that's a plus. I always say I like farm boys and gearheads, people that have actually liked working with their hands. If you're not really a great student in class, but you learn by seeing and doing and putting your hands on things, those are the kind of people that work out the best for us.
Okay. I'll welcome any other questions.
Yeah, we have one question at Tech High. Yeah, you want to ask?
What is the hardest position to fill at your facility and why?
Well, I guess the hardest position is a CNC machinist, a full setup and operator kind of a person, because as I said, it takes several years to get to that skill level, and because of the years of pushing students to go to college instead of looking at careers in manufacturing, and a lot of the VOTech type programs and that fed into our world had been stopped by the schools. And so we have a gap of people that have not been trained. And so it's hard, to find a skilled CNC machinist is virtually impossible. And that's why we have an apprenticeship program. So we're growing our own.
Good question. And what software are you using for CNC?
We use SolidWorks to do the modeling and everything. Today we generally get on a new part, we will get a solid model from our customer and whatever software system they're using. And then we use SolidWorks to convert it into the models that, like, to make a part, a complex part especially, it may take several operations. And so we'll have to draw up a model of each operation and then dimension it and make the inspection forms and everything for that. For the actual tool path, we use Esprit, which is the high-end CNC programming, and that's where you get to use the programming language to convert the dimensions and everything in the solid model into an actual program for the CNC machine. And they're similar, there's a lot of different kinds. I know a lot of the schools are using SmartCam and that to learn, and some have SolidWorks. But I mean, I think Inventor and that is all similar too. I know a lot of schools have that.
Right, any more questions?
How many schools do we actually have attending?
So it looks like we have about 5. Is that correct, Daniele?
I found about 4. I just need to know VOLTEV. That's a school or someone?
That's from Tech. He's from Tech High.
Okay, thank you.
And there are two separate classes here from Countryside High.
Okay, wonderful.
Perfect. Thank you, Teresa.
And Teresa, what is it all high schools with us?
Yes.
Okay.
Yes, they're all high schools.
And we hope to see you all on our in-person tours as well. We are still going to be setting up some in-person tours to go visit with local manufacturers. So we hope that you'll be able to do that as well. Do we have another question, Dunedin?
No, I don't think we have any more questions, but we would certainly be interested in a tour. As every other high school experience, the biggest trouble with is setting up the paperwork, getting a bus, funding a bus, and but any navigation and help we could get with that to get there, we'd love that.
Okay, absolutely. And we are setting up tours currently. I'm working with the CTE director. We're setting up tours for this month and next month, but we don't have to stop there. We can also continue setting up tours after the first of the year. So if it doesn't work out now, we can definitely set something up for after January.
That'd be great. Thank you.
So we definitely want any school that wants to come, we want to make it happen.
And if you know Michael McCullough, he can probably help you with the bus arrangements and that sort of thing.
Oh, yes, he's been great so far. Excellent. Yes, thank you.
So Roy, a little bit earlier, we were talking about 3D printing and, as far as that being an emerging technology and starting to have, different uses, first it started with prototype and fixtures, now looking at going into actual produced parts using 3D printing. But how does your company stay up to date with industry trends or innovations that are coming up, new technologies and things like that?
Well, we belong to a number of different groups, BAMA being one of them, and we have some technology roundtables we just had one recently, another one coming up soon. So we learn from those kind of things. I'm also a member of NTMA, and the same kind of thing. Those are, that's a nationwide organization. And so there's always information at the conferences and everything on technology. The Association for Manufacturing Technology is the trade association for the machine tool builders. And every other year, on the even years, so not this year, but next September, they have one of the largest manufacturing technology shows in the world in Chicago at McCormick Place. And so we typically have a half a dozen people go up there to see what's new and learn things and see what we can apply to make our company better.
Wonderful.
And, as far as the 3D printing, I mean, there's, you're right. It's moving into certain niche type production things. I mean, sometimes they're printing metal, exotic metals in some cases, and doing some very intricate things for small volume production. Maybe for a space shuttle or for the Orion or something like that. There's certain parts that can be made that way. So one of the things that it takes is for the engineers to design for 3D printing, because if they don't design it that way, you can't. You can make it a lot cheaper the way we're doing it than doing it by 3D printing. But if they design right, you can make an intricate part that we couldn't machine, or we would have to machine two different parts and they'd have to be assembled together or something like that. So that it's all progressing. The material properties are getting better. One of the things that stop us from doing it, really, besides the speed and the cost, is the material properties. When an engineer designs something, we make a lot of fuel control parts, and they're used on jet engines for 737s and A320 NEOs, and a lot of times they're subjected to very high temperatures and pressures. So the engineers have designed these things using the material properties that exist. And so to 3D print it, you'd have to be able to duplicate those properties. And that's slowly coming about, but it's not there yet for full production.
All right, so we have a few more questions in the chat. Where are you located?
So we're just north of Tampa Airport. We're between Hillsborough and Waters, just off of Benjamin Road. So just directly north of the airport. Easy to get to from Pinellas County.
And what materials are you primarily working with?
We use aluminum a lot. Again, we don't have our own product, so everything we make is designed by our customers. So when you're talking about aircraft, weight is a very important issue, and so they'll use aluminum as much as possible because it's lighter than steel. We machine a lot of titanium, which again is a very tough material, and the strengths and everything compared to the weight is very advantageous for some designs. When it's near the hot part of the engine, we're machining a lot of Inconel 718, which is a very high nickel alloy, very expensive material, very costly to machine. It eats up the tools because it's so tough, but it serves the purpose because it withstands heat very well.
And these questions are coming from Mr. Mills. So we have one more question. You mentioned working with exotic metals. I know that most companies do their best to recycle leftover metals from the CNC process. How do you deal with sorting out different types of metals for recycling?
Yeah, we keep all the chips separated. We have a big dumpster in the back for mostly aluminum chips because that's most of what we produce. But then we'll have a smaller dumpster for titanium and some barrels for the high nickel alloys and everything. So the recycler will come in and pull the dumpster out full of chips and put an empty one in and take the barrels and that sort of thing. And then they squeeze it down into like bricks or pucks, and then sell it back to the mills to be melted down and recycled.
Thank you for your questions. Great questions. All right, do we have any other questions?
Just as a thought, when you're thinking about your career path coming out of high school, in a manufacturing company like ours, in an apprenticeship program, you're paid from day one. There is no student debt. You're not paying any tuition to the school. So, at the end of 4 years, you could be making, I don't know, $20, $25 an hour easily, and not have any debt. We have some of our recent apprentice graduates that, recently bought houses and that sort of thing because they don't have any debt to pay off. And they got a really great career.
And that's very important. You start out, very strong, and then you can just keep building your career from there.
We had a question at Tech High. One of the students wanted to know, what is the most intricate or the most troublesome part that you ever had to make? Do you have something that sticks in your mind about something that actually gave you guys some trouble, actually either making, or it was really intricate and took a lot of your skills in order to figure out how to actually manufacture a part for a client?
Yeah, we've had many of them. I don't right now. We're making some really complex, large aluminum parts that go into a rotary vane actuator on a jet engine. Don't know exactly how it's used, but there's 2,000 features that you have to machine and measure. We make something that we call rocket tubes, but they're made of several parts that are electron beam welded together. So we're buying castings, we're buying material, and we're machining it, and it becomes a long tube with the outer section has a close bore on the inside and has two keyways that are welded the whole length of the tube. And then there's a smaller one that fits inside it and rides on those tubes. And again, the one's made out of 3 parts, one's made out of 6 different part numbers. Electron beam welded together. The inside one's chrome plated, the outside one is painted. It takes us over a year to make a batch of parts from the time that we get an order and have to buy the material and everything. But these units mount around the engine of an F-15, F-16, and they actually work the afterburner system. So if you've seen it when a pilot kicks a fighter into afterburner and the clamshells on the back close down, these tubes that we make actually actuate those clamshells to close down. And so that's a very intricate part.
On that note, could we have a follow-up question about what is like the security? Do you have to have security clearances for some of your employees because of that? Because you do government work and you do that, is there something that you guys have to put in place as far as your security measures for hiring people, or background checks of some sort? What goes on? Can you speak to that?
Yes, we don't have anything that requires a quote security clearance, but we are what's called ITAR, and so our employees have to either be U.S. citizens or green card holders. So we're not allowed to hire any foreign people. And as far as cybersecurity, we have to have all kinds of computer safety things and that put in. But that's primarily it. Again, we're not making any top secret stuff that requires security clearances.
And Roy, we have another question from Mr. Mills. How much of your manufacturing is hands-on versus automated?
I'm not sure exactly how to answer that. I mean, we do still have some what we call manual machines, like Bridgeport or manual lathe. Our tool makers use those to make fixturing and tooling. Um, so there you may be, the spindle is still turning by itself, but you may be moving the table with a crank. But the vast majority of it, the actual machining process is automated. Um, Most of the machines require changing the parts. If we have a fixture to hold a part to be able to machine it, the machinist has to be able to take that part off and load a new one. So that part is generally, is manual, but the machining itself is automated. So we have a system of 3 horizontal machining centers. So these are machines that have horizontal spindles, and we mount the parts on pallets, on tombstones, we call them. And we have 3 machines hooked up to an automated system. So we have a vehicle that is moving pallets around down to the setup stations where, again, the operators still have to change the parts and then measure them. We also have a few years ago put in a cell for parts that are higher volume for the 737 and A320. And so we have 2 twin spindle lathes with twin turrets, which are holding the tools. They're 4-axis, they're live tools, and we have a robot to tend them. So some of the parts are being loaded and unloaded by the robot, and they'll put them in a tray, and maybe a dozen parts in a tray, and whoever is responsible for tending it will then pull the trays out and measure the parts as necessary and put the trays back in. But for the most part, the actual handling of the parts is done by the robot in that.
And one of the students would like to know if you have summer-only internships.
Generally not. If somebody was really interested and that was the only way they could do it, we'd at least entertain it and talk to them about it. But primarily, we're looking for people that want to continue their careers, and they can work full-time in the summertime, but then part-time during the school year too, as long as you have the transportation and everything to get here.
Okay. And where another student from Dunedin High School would like to know where online is the best place to find a position, submit an application for an entry-level position with your company.
Well, our website is smt-tampa.com, and there should be a place on there that you can do an application. Our HR person email is shannon@smt-tampa.com. So emailing her a resume and everything is one of the better ways to do it also.
Okay, wonderful. And Teresa or Daniele, can you also put that information in the chat for the students?
Sure, of course.
Thank you so much. All right. What other burning questions do you all have? We got a couple here, I think. Anything else that you're thinking of that you'd like to ask Roy? Roy, what, can you share maybe some significant challenges your company has faced and how you've overcome them?
Well, in the manufacturing world, there's always challenges. We've grown from 5 people to 100 people. The machines are very expensive. The cell that I talked about with the two machines and the robot was $2 million investment. So coming up with the financial ability to be able to do that kind of thing, we're we're paying people every week. We're buying material, we're buying tooling. We're having parts done with anodizing and heat treating and things like that that are part of the parts. And so we're carrying $5 million in inventory, $3 million in receivables. The expense of our payroll is $125,000 a week. Our health insurance, which we have full benefits, we pay the majority of the health insurance for the employees. That's over $40,000 a month. So the financial part of it has always been a challenge. It's really hard to grow, invest in those kind of machines because it takes a while for them to pay off. Certainly the skilled people issue has been around for a long time. It's particularly acute now, finding skilled people. We could easily get more business if we had more skilled people to be able to do it. Today and since 2020, there's been inflation. Our material costs have gone up. That finding some of our outside supplies, some of our material has become very hard to get. We have some materials that it takes us a year to be able to get them, so we have to be able to forecast out that long. Those are all challenges that we're facing every day.
And Dunedin would also like to know if you ever have engineers or any of your company reps visit with the schools. So go out to the schools and visit with the students.
We've done that a few times, and we'd be more than happy to do that again if there's a particular certain situation, a certain class that you'd like somebody to come and talk to. We'd be happy to do that. And our engineers, we call them engineers or process engineers. It does not require a college degree in engineering. It's really because we're not designing the parts. You don't have to have a mechanical engineering degree. So really, a machinist that has come up through the ranks, learned how to make the parts, learned how to read the programs, learned how to program, they make our best process engineers is what we have, because they know enough about what the machines are capable of and how you need to hold the part to be able to machine it. So it's really more of an experience than it is a college degree.
Any more questions? I think Mr. Mills said that their bell's getting ready to ring, but he wanted to thank you, Roy, for being so generous with your time. So thank you all for attending.
Yeah,
And
thanks.
the recordings will be available, and please check the chat for the contacts for SMT.
Thank you.
Thank you all for attending, and whether it's SMT or someone consider a career in manufacturing.
Thank you, Dunedin.
Thank you.
One of the students says he likes your tie.
Thank you.
See,
That's one of my
he can
signature things.
Roy can also give you advice on how to dress, so how to look sharp.
All right,
So-
and thanks from Tech High. Thank you.
Thank you.
Tech High.